Too hot, too barren, too difficult to land on and too bland. These things have all been said about our first planet, Mercury. Indeed, even on this very channel, it's the last planet that we've dedicated a full video to. We documented most of the larger moons of the solar system, Ganymede, Callisto, Triton, Titania, Rhea and company, way before Mercury. But the truth is that Mercury, far from being a boring planet, is actually quite uniquely fascinating. Hi everyone, Vega here, and in today's video we return to our solar system series to document the first planet from the Sun, and indeed whether we could possibly live there. So let's get to it. Many of you may have come across the What's Next channel, and I'd advise you to take a watch of his latest video documenting whether Mercury is better than Mars or the Moon for colonisation. In brief, What's Next seems certainly to be a big fan of Mercury, and I have to admit I'm starting to come around to that way of thinking myself too. As a human exploration of our solar system begins over the next century, the possibility of establishing settlements on planets beyond Earth will begin to become more science fact than science fiction. They certainly capture our imagination, but one thing is paramount to everything: H2O or water. Mercury may seem completely inhospitable due to its extreme temperatures, but scientific investigations have unveiled the presence of large amounts of water ice in the polar craters, which remain permanently shadowed from the Sun, protecting the ice from solar radiation. Basically, what's got me so enthused with Mercury is that the temperatures within some of these very craters also appear to have a sweet spot. If we look closely at this graphic, we can see that there are actually regions of Mercury in and around the poles that do not experience impossibly extreme temperatures, and indeed they appear to be in the realms of human comfortable temperatures, which on this graphic is around 270 to 300 or so Kelvin, some -3 to 27 degrees Celsius. It's normal, isn't it, between some point at plus 400 degrees Celsius and minus 180, at some point we have to reach an equilibrium. That said, sure they will vary, and probably much more even than Siberia's wildest extremes, but we can't rule them out anymore, or should I say, it's not impossible to habitate given adequate protections. So, we have water and we have potentially comfortable temperatures, and not only this, but the ice enables production of essential resources too. I think one of the most striking things of the past 5 to 10 years of solar system thinking and explanations is that we're now going into much more details about planetary habitation, not just Mercury being too hot or Venus too hot and perhaps the rest too cold kind of thinking, but actually looking at areas within those planets where the norm is slightly different and theoretically could be more hospitable. The finding of ice on Mercury means it can be used for drinking water, irrigation systems for agriculture under pressure of course, and as a coolant to regulate temperatures in habitats. Additionally, water ice could be separated into oxygen and hydrogen, oxygen supporting breathable air within domed structures, and hydrogen serving as a potential fuel source for energy production. It's not all wonderful though, of course. One huge problem remaining is that Mercury has virtually zero atmosphere. Even our own moon has a substantial atmosphere compared to Mercury, and so in all likelihood we're going to have to construct either underground or solid dome structures. Such structures would provide us with a controlled atmosphere, shielding our inhabitants from the most intense temperatures and radiation, and absolutely from micrometeorite impacts. In designing dome structures, we could use carbon nanotubes or reinforced polymers which offer strength, durability and flexibility. These materials possess excellent thermal properties, which would enable the domes to withstand those very extreme temperature differentials. Indeed, transparent variants of these materials allow natural light to enter, which also reduces the reliance on artificial lighting. By creating an artificial seal, we would maintain a breathable atmosphere within the domes. That said, it's likely that multiple layers of protection would be required, probably including an inner membrane, insulator and outer shielding, which would of course enhance resistance to radiation and micrometeorite impacts. Regulating the internal climate would require heating and cooling mechanisms, air filtration and humidity control, which could be powered by renewable energy sources such as you might imagine by solar panels, taking advantage of the vastly abundant sunlight on Mercury's surface. We should still not get too far ahead of ourselves. Landing on Mercury indeed possesses unique challenges due to its proximity to the Sun and the planet's characteristics. Intense gravitational pulls from the Sun and lack of atmosphere necessitate careful planning and advanced technologies for successful landings. It's not easy to land on Mercury, and this adds great cost. The good thing though is that Mercury itself has vast mineral resources, so much material could be sourced from the planet itself and not needed to be imported from elsewhere. Mercury's long day, which lasts approximately 59 Earth days, also presents its own set of challenges. The long day-night cycle will require energy storage systems to sustain continuous power supply throughout the prolonged night. Innovative solutions like battery technology or the utilization of nuclear power could be required to address the challenge effectively. Once we've built these initial settlements, we might then wonder how many people we might actually be able to fit inside, or to determine the population capacity of such settlements, so to speak. Given the limited habitable space within the polar craters, it is reasonable to speculate that initial populations would be modest, probably consisting, a bit like in Antarctica, of small groups of scientists, engineers, support staff, possibly numbering the tens or even hundreds. Primary focus would be on conducting research, refining technologies, and establishing sustainable systems to support those larger populations in the future. As infrastructure and resource utilization improves, it may then become possible to expand the population. Efficient use of space and advanced vertical farming techniques could increase agricultural productivity. Continued advancements in recycling systems and renewable energy generation and resource extraction methods would also contribute substantially to the growth of the settlement. We must bear in mind that once we arrive and settle on Mercury, we're not limited to craters though forever. Solar shields could be built leaving our dome settlements in the shadows, a bit like replicating the craters themselves, and therefore cooler. Baking surfaces outside would provide storage heating for those cooler nights, and we could push further out into the more inhospitable areas of Mercury given time and patience. As long as the sun is shielded sufficiently, or even permeated by intermittent blinds, then temperatures should theoretically be reasonably easy to regulate. Mercury is a planet that's difficult to see in the glare of the sun. It's long been thought of as a waste and barren land, not too dissimilar from our own moon. Like our moon, however, recent discoveries suggest that there may be large water reserves, and not just that, but that Mercury has far more even than the moon. Once we find water, the construction of solid dome structures and overcoming landing challenges are critical steps towards establishing sustainable habitats. As humanity's understanding of space exploration advances, so Mercury for once begins to step into its rightful place in the limelight, and may just prove that, contrary to initial beliefs, it could provide one of the most Earth-like situations within our entire solar system. Thanks for watching, and consider subscribing if you haven't already. If you'd like to support the channel further, you could consider buying me a coffee, and I'll link this in the description. Thanks to those of you who have already done so. And if you have any videos or subjects you'd like to see brought to life, let me know in the comments below, and perhaps next week your idea could show up. Take really good care of yourselves, look after your friends and family well, and I'll see you on the next one.